Good morning, everyone. Uh, today's I'll do the continuation of Module 5. Uh, so, in this video, we are seeing what is pipe. I mean, the first topic is what is pipe means. So, in our microcontroller and embedded system, pipe is a method used to pass information from one program process to another. From one program process to another, the information should be passed. So information, the passing method is called a pipe. Information passing method is called pipe, not the uh, what is it, not the material where I mean what, not the transporting thing. Transporting, I mean bus means it is going to transmit the data, right? So the the pipe and bus are not same. Okay, so pipe is a method is used to transmit the data. Unlike other type of inter-process communication, a pipe only offers one-way communication. That is important. A pipe is only one-way communication. By passing a parameter or output from one process to another, this information that is passed through the pipe is held by the system. The information that is passed by the pipe is held by the system until it can be read by the receiving process. ಅಲ್ಲಲ್ಲ ಮುಟ್ಬೇಡ. Okay. Unlike other type of inter-process communication, pipe only offers one-way communication by passing a parameter or output from one process to another. So the information that is passed through the pipe is held by the system. If your pipe is passing any information, that will be there in the system until the receiver is receiving that. Okay, receiving process is receiving that, it will be in the pipe only. Also known as first in first out for its behavior. Means the first process which is transmitted through pipe until it is received, then and I mean first out it until it first out, the pipe is fully occupied. Okay, so in computing, a named pipe, also as a first in first out, is one of the method for inter-process communication. For inter-process communication, this is also one of the method. It is an extension of the uh, traditional pipe concept on Unix. Okay, in Unix, the pipe concept is there. The same thing is the same thing is used. Okay, so it is an extension to the traditional pipe concept on Unix. A traditional pipe is unnamed and last only as long as the process. Okay, a traditional pipe is unnamed and last only as long as the process. Okay, I mean it is not named and it lasts only as long as the process. The named pipe, however, can last as long as the system is up. Okay, means until the system is up, it is uh, what is that, pipe will be available. Okay, beyond the life of process, it can be deleted if no longer used. Means in the pipe we can transmit the data from one process to another. So until the receiving process is receiving it, it will be there in the uh, pipe. Okay, so once the life beyond the life of process, it can be deleted if no longer used. If it is no longer used, then we can delete it. Usually a named pipe appears as a file. Okay, it appears like a file, and generally processes attached to it for inter-process communication. For inter-process communication, the process is attached to this pipe only. Okay, a f first in first out file FIFO files is a special kind of file on the local storage which allows two or more processes to communicate with each other by reading, writing to or from this file. Okay, a first in first out file is a special kind of file on the local storage which allows two or more processes to communicate with each other by reading, writing to or from this file. A first in first out special file is entered into file system by calling mk file in FIFO. Okay, in C mk FIFO, that is the function name. Okay, so this is the function name which is used to call the first in first out special file which is entered to the file system. Once we have created a FIFO special file in this way, any process can open it for reading or writing. Okay, any process can use this for reading and writing in the same way as the ordinary file. However, it has to be open at both ends simultaneously before you can process to do any input or output operation on it. Okay, so this is about the file. Next is message passing. So uh, message passing can sorry this is about pipe here. uh, Repeat once again. The file means which is used to inter process communication to transmit any information. Okay, and the previously when traditional pipe which is used in the Unix, it is like a unnamed, so the last only it will remain only as long as the process. If the process ends, the it will get over. Okay, so here in the pipe, it will transmit the named pipe. However, it can last as long as the system is up, and till the system is up it can be it will still be there, it will be there. Okay, so beyond the life of process it can be deleted if no longer used. It is not longer used, then it can be deleted. um, with the named pipe appear as a file, generally process also is attached it for inter-process communication. A FIFO file is a special kind of file on the local storage which allows two or more processes to communicate with each other by reading or writing to or from this file. The FIFO special file is entered into the file system. I mean, so to use this FIFO or the file system, pipe, to use this pipe, we have to create this FIFO special file. We have to create the FIFO special file. To in the file system, by calling this one function called mkfifo. Okay, there is a function name. If we are calling this function, then it is in the C. Once we have created this FIFO special file in this way, any process can open it for reading or writing in the same way as an ordinary file. However, uh, it has to be opened at both ends simultaneously. Okay, so the next topic is message passing. So message passing can be synchronized or asynchronized. There is two type of message passing. It is synchronized and asynchronized. Synchronized synchronous message passing system requires The sender and in asynchronous communication, the sender and receiver do not wait for each other and can carry on their own computation while transfer of message is being done. Okay. Uh, so first we should understand this. What is synchronous and asynchronous? Synchronous message passing system requires sender and receiver to wait for each other while transferring the message. Means it is like how we are talking in the walkie-talkie. The walkie-talkie, first, not walkie-talkie. That is like uh, one way, two-way communication, but it is a half duplex. Okay, half duplex means once one person can send it, then he should wait for the next one. The receiver person can send the information, only the sender person is allowing him. So this is one example we can consider. Or other way, the synchronous message passing means first it is like a requesting for receive the data. Then sender is asking whether you are ready for receiving the data. So this acknowledgement should be done. Okay, so that is happening in the synchronous message passing system. In asynchronous, the system will say, in asynchronous communication, um, sender and receiver do not wait for each other. Okay, sender will keep on sending the data, receiver, if when it is ready, it will receive the data. The advantage of synchronous message passing um, is that it is conceptually less complex. Okay, in synchronous message passing, like we know receiver is ready, so it is sending the data. So after sending the data, receiver is acknowledging, saying that it is received data properly. So there is like it is not a complex one. We know like when it is received, when it is transmitted, all these things. So synchronous message passing is analogous to a function call in which the message sender is a function caller and the message receiver is a called function. Okay, synchronous message passing is analogous to a function call in which the message sender is the function caller. Okay, who is sending the message is a function caller and the message receiver is a called function. So who is receiving the function is calling the function. Okay, so function calling is easy and familiar. We know, right, how to call the function. Just as a function caller stops until the call function complete. So if there is some function in between the in the main function, if we are calling on function or calling on subroutine, so it will wait for completing that subroutine and come and start executing the main program. So the sending process stops until the receiving process completes. Okay, so this alone makes a synchronous message unworkable for some application. For example, if synchronous message passing would be used exclusively, large uh, distributed system generally would not perform well enough to be usual. Such large distributed system may need to continue to operate while some of their subsystem are down. So subsystem may need to go offline for some kind of maintenance or have time uh, when subsystem are not open to receive input from other system. Okay, so this is the problem of synchronous communication. Okay, so the next topic is message queue. So message queues provides an asynchronous communication protocol, asynchronous communication protocol, meaning that the sender and receiver of the message do not need to interact with the message queue at the same time. Message queue provides an asynchronous communication protocol. Okay, Asynchronous communication protocol, meaning that the sender and receiver of the message do not need to interact with the message queue at the same time. Means whenever sender want to send the data, it is going to put in the message queue. When the receiver want to receive the data, it is reading from the message queue. That is this is a explanation for asynchronous communication. Okay. uh, so I mean, asynchronous communication means it is not synchronized between sender and a receiver. Okay. I mean, same time when sender is transmitting the data, it is not compulsory that receiver should receive that data, okay, at the same time. It can receive it after some time. So that is what the use of this asynchronous protocol. So it should put somewhere, right? So if it is not synchronous, if the receiver is not ready to receive the data, then where it is that sender is going to send the data. So for that, this message queue is created. So message queue interact with that that sender and receiver of the message do not need to interact with the message queue at the same time. Okay. So messages placed into queue are stored until the recipient, means receiver, retrieves them. Message queues have implicit or explicit limits on the size of data that may be transmitted in a single message and the number of messages that may remain outstanding on the queue. Many implementation of message queue function internally within an operating system or with an application. Such queue exists for the purpose of that system only. Other implementation allow the passing of message between different systems, potentially connecting multiple application and multiple operating systems. These message queue system typically provide enhanced resilience functionality to ensure that message do not get lost in the event of system failure. If the system failure happens, the message will be there in the message queue. Example of commercial implementation of this kind of message queuing software, also known as message oriented, include IBM WebSphere MQ, formerly MQ series, or Oracle Advanced Queuing AQ. There is a Java standard called Java Message Service, which has several property and free software implementation. Implementation exists as a mm, proprietary software provided as a service, open source software, or a hardware based solution. Okay. Here in the slides, I have not put that. Wait, I'll put. Okay. You can see here a message queuing, that is block diagram. The sending process. Okay. So sending process and receiving process. There is two process. Now message passing module, it will send the data, the information what it want to send, it will pass to the message passing module. So from the message passing module, it will be stored into the message queue. And receiving process, it will retrieve the data from the message queue through a message passing module. So from the message passing module, the receiving process will receive the data. So it is not necessary that same time it should when sending process is sending the data to the queue, same time receiving process is should be received from the queue. It is not required like that. Okay. So sending process can send the data to message queue. Whenever receiving the process is free to want to receive the data, it can go and receive the data from message queue. This is what the asynchronous concept of message transferring. Next one is message, sorry, mailbox. Okay, next is mailbox. So mailboxes provides a provides a means of passing messages between tasks for data exchange or task synchronization. Mailboxes provides a means of passing messages between tasks for data exchange or task synchronization. For example, assume that a data gathering task that produces data need to convey the data to the calculation task that consumes the data. This data gathering task can convey the data by placing uh, it in the mailbox and using the send command. The calculation task uses receive to retrieve data. If the calculation task consumes data faster than uh, gatherer uh, produces it, the task need to be synchronized so that only new data is operated on by the calculation task. Using mailboxes achieved synchronization by forcing the calculation task to wait for new data before it operates. The data producer puts the data in the mailbox and sends it. The data consumes task called receiver to check whether there is a new data in the mailbox. If not, receiver calls the push function to allow other tasks to execute while the consuming task is waiting for the new data. Okay, I'll repeat it. Mailboxes provides means of passing message between task and data exchange for task synchronization. For task synchronization, the mailboxes provides means of passing message between task and data uh, between task. Between task, data exchange will be done through mailbox. Between process, data exchange can be done two way. One is message queuing, one more is a direct transmitting from transmitter to receiver. We can transmit that is called a synchronizing method. Second one is a asynchronous method. We are using a what is that, um, message queue. Okay, the message queue is used for a asynchronous method. For synchronous method, we can directly transmit and receive the analogous function which will transmit and receive. But the problem is if it is a large file, then it is simply wasting time for transmitting and receiving. Okay, because until the receiver receives data completely, it will not execute the main functions. But in the task, there is mailbox is used. Mailbox is used mm, between for a data exchange or task synchronization. We'll assume that data gathering task that produces data need to be convey the data to a calculation task. There is one task, data gathering task means it should receive the data. Okay, data gathering task means I can give one example like in your mm, what is that, calculator. You are giving the data, that is numbers what you are entering, that is a data gathering task. It means when you are pressing the key, it should receive that data. That is a data gathering task. And convey the data to the calculation task. It should do some calculation. So calculation task that consumes the data, this data should go to the calculation task. This data gathering task can convey the data by placing it in the mailbox. So what you are typing, the numbers, that will be placed in the mailbox and using the send command. Okay, like you are giving the putting the input like 3 into 3 equal, right? So that send command, we want to find what is the equal of that. So send command, the calculation task uses receive to receive to retrieve the data. There is it is going to receive it to retrieve the data. If calculation task consumes data faster than the gather procedure produces it, the task need to be synchronized so that only new data is operated on by the calculation task. Means when you are pressing 3, okay, uh, if the that if the calculation task receive that, you are still not removed your hand from the number 3, right? So it will think that it's second time again you have pressed the 3, right? So that should not happen. That's why there should be a synchronize between uh, the task, there should be synchronization between what is that gathering task and the retrieving task or receiving calculation task, okay? So the tasks need to be synchronized so that only new data is operated on by the calculation task. Using mailbox achieves synchronization by forcing the calculation task to wait for a new data before it operates. Okay, it will wait for the new data before it is uh, operate. The data procedures puts the data in mailbox and send it. The data procedure puts the data in the mailbox and sends it, okay? And that's why first it will gathering task will receive all the data and put in the mailbox and send it. The data consuming task calls receive to check whether there is new data in the mailbox, okay? If not, receiver calls the pause to allow other tasks to execute while the consuming task is waiting for the new data. If there is no new data, it will keep on checking the mailbox, okay? The receiving task will check the mailbox. If no data is there, then it don't have to do this calculation task, so it will give the uh, permission for other tasks to execute, okay? It will go to the pause, okay? The next topic is signaling. Now, signaling are commonly used in POSIX system, okay? Signaling is commonly used in POSIX systems. Signals are sent to the uh, current process, telling it, okay? Signals are sent to the current process telling it what it need to do, such as shut down or that it has committed an exception, like that, okay? A process has several signal handler which execute code when a relevant signal is encountered. A process has several a process has several signal handlers which execute code when a relevant signal is encountered. The ANSI, ANSI, the ANSI standard, okay, uh, header for these tasks is signal.h, which includes routine to allow signal to be erased and read. Whenever a signal is erased, its signal should be allowed and it should be raised, okay? Raised and read. Signals are essential software interrupts. It is possible for a process to ignore most signals, but some cannot be blocked. Signals are essential software interrupts. It is possible for process to ignore most signal, but some cannot be blocked. Some of the common signals are segmentation, violation, Segmentation violation, reading or writing memory that does not belong to this process. Next is illegal instruction, that is trying to execute something that is not a proper instruction to CPU. Then halt, that is a stop process for the movement. And continue, used after a halt. Next, terminate, clean up and quit. And kill, quit now without cleaning up. These are the type of signaling. These are some of the signaling uh, in the POSIX system. Okay, so I'll end this video here. I'll continue the next topic in the next video.